So we were discussing uh, questions of real integrations in last class, and that discussion I am going to continue. Uh, we did many questions, and just to revise from where we started, uh, I told you that for integration minus infinity to plus infinity, some function of x dx, that is 2 pi I sum of residue for the poles above the real axis, and pi I sum of residue for the poles on the real axis. For the poles on the real axis. Okay. So using this formula, uh, we have already calculated many integrations. Okay. So today also I will take a few integrations using this formula, and the next integration is this. Please note down the quantum mechanical scattering. Note down the quantum mechanical analysis of scattering. The quantum mechanical analysis of scattering leads to a function I is equal to minus infinity to plus infinity x sine x over x square minus sigma square dx, where sigma is some real and greater than 0. That means positive number, real and positive number. Sigma is real and positive number. Okay. Now we have to calculate this in, and this will be an example uh, to just show you that even our this analysis is used for actual purpose. For example, you see uh, in some you are doing some scattering calculation in quantum mechanics, and you come across this function कि अगर ये integrate कर लो तो you will get the intensity of scattering. So how you will do that? Okay, so we will use the concept of contour integration to solve this problem. So this will be a very good example to tell you how this complex analysis works in physics. Okay, so let us take this. Not a tough one, because seeing this we have to write a function like we did for each and every question. So the function fz will be, it will be very easy, z e to the power iota z over z square minus sigma square. I told you that for sin x we have to write e to the power iz, and for cos x also we have to write e to the power iz, and then we take real or imaginary part accordingly. So what we will take in this question, real or
Amazing.
Imaginary.
imaginary? Okay, very good. So you remember that we have to take imaginary. So please see this is very easy. So now your fz will become z e to the power iota z over z plus sigma and z minus sigma. Please check this. This is okay. And which pole we have to consider?
Plus sigma. Sigma.
Answer is wrong.
Both.
Sigma is real.
Both
So
sigmas.
both,
Both sigmas. Yes, sir.
both will be considered. So this is your semi contour. This is 0. Sigma will be here, minus sigma will be here. So both has to be considered, no problem. Okay. So let us calculate the residue. And what type of poles they are? Yes?
Sir, but you have written sigma is greater than 0 belonging to real number.
हाँ, I have.
So फिर माइनस सिग्मा कैसे इंक्लूड करेंगे?
ये देखो ना कैसे बनाया है. मान लो सिग्मा 2 है, तो 2 यहाँ होगा, माइनस 2 यहाँ होगा. तो इसको छोड़ेंगे क्यों, ये बताओ आप. व्हाट इज द रीजन व्हाई आई शुड लीव दिस? भाई सपोज सिग्मा इज रियल एंड ग्रेटर देन 0, so let us consider that sigma is equal to 2. So 2 will lie here, minus 2 will lie here, both will lie on the real axis. So both will lie on the real axis. तो क्या मैंने ऐसा बोला है कि negative real numbers has to be omitted? I have told that? No. मैंने बोला है कि every number lying on the real axis and above the real axis has to be included, and numbers below the real axis has to be excluded. यही तो बात हुई थी. Okay.
Yes, sir.
So both are simple poles. You can see both are simple poles. Okay. So calculate the residue. Calculate the residue. Let us calculate the residue for which one? For z is equal to sigma, let's say. So it will be limit z tending towards sigma, z minus sigma into z e to the power I sigma over z minus sigma z plus sigma. This will be cancelled and put z is equal to sigma, so it will become sigma e to the power I sigma over 2 sigma, which is e to the power I sigma by 2. Okay. Yes. And what about the next one? What about this? Z is equal to minus sigma. What about this? So we will have to consider limit z tending towards minus sigma, z plus sigma, z e to the power iota sigma over z minus sigma and z plus sigma. Okay. So z is equal to minus sigma. So it will become minus sigma e to the power minus I sigma over minus 2 sigma. So this will be cancelled. So it will be e to the power minus I sigma by 2. Okay. So now finally, what is the value of integral? That will be imaginary of, you remember? Imaginary of pi I sum of residue, and sum of residue will give e to the power I sigma minus e to the power minus I sigma upon 2. Yes?
प्लस आएगा ना sir?
sorry, plus. So this will become I will be equal to imaginary of pi I cos of sigma. So the answer will be pi cos sigma. Is that okay?
Yes.
So cos sigma is the scattering profile. So अगर आप थोड़ा सा वैसे देखो तो इसका मतलब क्या हुआ कि कुछ स्टैंडिंग वेव टाइप की बन रही है, तो स्कैटरिंग वेव जो है फाइनली दैट इज कॉस सिग्मा ओनली ना. सो एक कॉस का सिग्नल दिखेगा, दैट मींस कुछ इधर से आया होगा, कुछ उधर से आया होगा, एंड फाइनली द स्टैंडिंग वेव हैज फॉर्म.
सर ये यहाँ पे अगर साइन साइन सिग्मा है, यहाँ पे अगर साइन 2 सिग्मा होता, कैन वी राइट दिस?
साइन 2 सिग्मा कहाँ पे?
जहाँ पे सॉरी साइन एक्स है, यहाँ पे साइन 2x होता, तो
तो
कैन वी राइट दिस?
e टू द पावर i 2z लिखना पड़ता फिर.
इमेजिनरी ऑफ e टू पावर i2z.
2z.
सर अगर e टू पावर i2z ना करके पूरा लिखें e टू पावर i2z प्लस सॉरी माइनस 1 अपॉन e टू पावर ये
e टू
करके
द
तो
नहीं एक्चुअली ये जो x साइन x है ना,
यस
ओवर एक्स स्क्वायर माइनस सिग्मा स्क्वायर, तो ये जो साइन ऑफ एक्स है, ठीक है, इसको e टू द पावर आई जेड से रिप्लेस करना होता है.
ओके सर.
साइन और कॉस को, साइन एक्स और कॉस एक्स हैज टू बी रिटन लाइक e टू द पावर आई जेड, एंड फाइनली रियल और इमेजिनरी पार्ट. बाकी x की जगह सीधा z लिख देना. ओके एक्चुअली
नहीं
इसके
सर अगर 2x होता है यहाँ पे साइन
तो कोई
2x.
कोई प्रॉब्लम नहीं है, 2x होता तो कोई प्रॉब्लम नहीं है. तो इसको मैं लिख लेता z e टू द पावर आई 2z ओवर z स्क्वायर माइनस सिग्मा स्क्वायर.
ओके सर ओके.
Let us take another one. So next question, let me take minus infinity to plus infinity dx upon x square minus 3x plus 2 and x square plus 1. Okay, let us take this question. So this problem, what will be fz? 1 upon z square minus 3z plus 2 and z square plus 1. Yes. And what will be the factorization? Fz will be 1 upon, what will be factorization?
Z minus 2, Z minus 1.
Z minus 2, Z minus 1. And here?
Z minus iota, Z plus iota.
Z plus iota, Z minus iota. So these are the poles. What are the poles? 2, 1, minus iota and iota. This will be taken, this will be taken, this will not be taken, this will be taken. Because of your nature of the contour which we are using. Yes? So minus iota will lie somewhere here. All others will lie inside the contour. And 2 and 1. What about 2 and 1?
रियल एक्सिस पे लाइक रहेंगे.
They will lie on the real axis. Tell me. Yes? Proposition बताना.
Yes sir. Yes.
So it will be 0, 1, 2 and iota. So this will be the location of all the poles. Fine. And now let us quickly calculate for z is equal to iota. सबसे पहले z is equal to iota. So z is equal to iota. So what will be the residue? If I write z is equal to iota means, अब देखो ऐसे मन में कर लेते हैं, z minus iota will be multiplied, ये cancel हो जाएगा, it will be cancelled, and put z is equal to iota. So what you will get? Iota minus 2, iota minus 1, and 2 iota. Agree with this? What about z is equal to 1? अब मन में सोच के लिखो, z minus 1 multiplied होगा, that will be cancelled, and it will become, here you will
minus one.
minus 1 plus iota, 1
And
minus iota. So this will become 2, 1 square कितना हो जाएगा? A square minus B square. So it will become 2. So it will become minus 1 by 2. Okay? And the third one, z is equal to 2. So this will be cancelled. 2 here, what it will give? 1. 2 plus iota, 2 minus iota means 5. 2 plus iota, 2 minus iota. So this will be 1 by 5. If there is any doubt, please ask quickly. Okay? So now the final answer. Time to write final answer. That will be I is equal to pi I into sum of residues for this, and it is minus 1 by 2 plus 1 by 5 and plus 2 pi I and sum of residue. What is this? 1 upon I minus 2, I minus 1, 2i. Okay? So please see this. ये कितना आएगा? This thing will become pi I into
minus 3/10.
minus 3 pi I by 10. Huh? Yes? And 2i will be cancelled here. This will become 1 upon minus 1 minus I minus 3i and plus 2. So it will become 1 upon 1 minus 3i. So multiply by 1 plus 3i, 1 plus 3i. So it will become 1 plus 3i by 1 square plus this 10. Okay?
So pi also.
Sir, pi is there.
Sorry?
Pi.
Pi is there. So finally what will happen? It will be minus 3 pi I by 10 plus pi is here. So 3 pi I by 10 plus pi is here. So pi by 10. So this will be cancelled and pi by 10 is the answer. Tell me if that is okay. I hope everybody understood this. If there is any doubt at any step, you can ask. So that is benefit of doing questions from a good book, that every question is different and requires a particular kind of a skill to solve. So you have seen that the residue at simple pole is so important for so many questions. Na? Ultimately, now you have been doing it for so many questions, so you know how to calculate. So let me take another question, and that is minus infinity to plus infinity. अब आप क्विकली अपने आप भी करो साथ साथ. X over 8 minus x cube dx. Okay, this is the question that we have to solve. So what will be Fz? Z upon 8 minus Z cube. Yes. And how to calculate the singularities or poles? 8 minus Z cube is equal to 0.
Cube minus.
So Z cube is equal to 8 and Z cube is equal to 8 into e to the power I 2n pi. याद है या भूल गए? So Z is equal to 2 into e to the power I 2n pi by 3. So what is Z0? That is 2. What is Z1? So if I take 1, what is the value of e to the power I 2 pi by 3? E to the power I 2 pi by 3. So you can see that it will become मन में ही सोच लो, it is like 120 degree na. If you convert it into degree, it is 120 degree. So what is cos of 120 plus I sine of 120? So cos 90 plus 30. Yes, it is going into second quadrant. So that will be minus half. And sine of cos of 90 plus 30, sine minus sine 30, and sine of 90 plus 30, so plus iota under root 3 by 2. देख लेना जरा एक बार. Is that okay? So Z1 is e to the power I 2 pi by 3. Okay. And what about Z2? E to the power I 4 pi by 3. Correct?
सर ई के साथ 2 भी तो है z की
2
वैल्यू
है.
में, तो वो
2
भी तो लिखेंगे.
2 सब में है. 2 is there. Okay. So these are the poles. Now we have to calculate the residues. So from here we can calculate the residue. Residue will become phi z by psi dash z, na? Minus 1 by 3z. Okay. So for z naught, what will be the residue? Minus 1 by 6. For z1, it will be minus 1 by 3 into 2 e to the power minus I 2 pi by 3. And Z2, what will be the residue? And please see, Z2 will be included or not, that we have to see. Like I saw for Z1, iota was positive, na? So it is included. And what about Z2? We will have to check that what is the value. Z2 will be 2 cos of, कितना होगा?
minus 1 by 2 minus
240 degree. And plus just समझाने के लिए लिख रहा हूँ, sine of 240 degree. Is this correct? Because 6 4 is 24. So it will become 360 minus.
सेम ही आ रहा है सर.
Sorry?
2 पाई माइनस करके सेम ही आ रहा
हाँ, सो कितना हो जाएगा?
I will be
360 360 माइनस लिख सकता हूँ ना 60 या 180 प्लस लिख दूं, दोनों में से एक
180 plus 5 by 3.
180 प्लस कितना होगा?
5 by 3.
60.
60 डिग्री में ही रहने दो, प्लस आई साइन
5 plus 5 by 3.
180 plus 60. Yes. So what will be value here? 2 cos 180 plus 60. It will become minus sin 60. And
No,
this? Huh.
No,
it doesn't
sir,
change
it
it around 180.
cos 60. It
Sir,
is cos 60.
रहेगा.
minus cos 60.
No, minus
Oh,
cos.
sorry.
Cos.
Sorry. Minus cos 60. And what about this?
Minus sin 60.
Minus I sin.
Minus I sin 60.
Sin.
So because of this reason, minus आ रहा है ना? So because of this reason, it will not be included. Okay. So only Z0 and this will be included. अब इसको लिख लो जरा. So what will be the answer? I is equal to 2 pi I and minus 1 by 6. पहला क्या है? 2 है क्या? First one is 2. So pi I minus 1 by 6 plus 2 pi I and minus 1 by 6. And what is the value here? Cos of 2 pi by 3 into cos of 2 pi by 3 and minus I sin 2 pi by 3. Okay. So this we have to write. इसको जरा ढंग से लिख लेते हैं. So this will become I is equal to minus pi I by 6 and plus 2 pi I minus pi I by 3 into, what is this value? Tell me. 2 pi by 3. Cos 2 pi by 3.
Minus 1 by 2.
Minus,
1 by 2.
and what is this?
Plus iota root 3 by 2.
Root 3 by 2.
Plus iota.
This is minus?
Plus iota.
Okay. एक बार और भी चेक कर लेना भाई कोई.
Sir, it is minus root 3 by 2 minus I 1 by 2.
No.
Minus 1 by 2.
Just wait,
Root
bhai,
3 by
wait,
2.
wait. Don't confuse everybody. So this is just sine 120, na? Yes. So that is sine 90 plus 30. Okay. So that is cos 30.
Okay, sir.
So what it will become finally? Minus pi I by 6. And what about this? Plus pi I by 6. And this plus pi root 3 by 6. हाँ, आप पूछो किसी को अगर कुछ पूछना है तो.
Sir,
Hmm.
sir, can we proceed with a cube minus b cube formula here?
Then you will have to, I mean, you will divide it that in two parts, and ultimately you will get 3 poles.
But sir, how will we get then iota? Because then quadratic will come and then a minus b will come. Then
So
quadratic's root will be in root.
मतलब आपको ये आइडिया नहीं है कि क्वाड्रेटिक से आयोटा कैसे आ जाएगा?
आ जाएगा सर,
क्वाड्रेटिक के रूट के
बाहर आ
अंदर।
जाएगा. यस सर, यस सर, यस सर, रूट -1 बाहर आ जाएगा. ओके सर.
बट अगर आपको इसमें इनर्शिया लग रहा है तो आप एग्जाम में क्वेश्चन नहीं कर सकते. आपको इसमें बिल्कुल स्मूथनेस रखनी है. आई मीन like the questions of kind 1 up dx upon 1 plus x to the power 4, that is a previous year question. Dx upon 1 plus x to the power 6, that is a previous year question. So you can't
Yes,
avoid,
sir.
you can't find other ways. There is no escape.
Yes sir, just asking sir. Thank you sir.
Sir, there is negative sign here.
Yes, sir.
Where?
Cos 30 positive.
Sir, in bracket.
यहाँ पे?
Yes.
Yes sir.
एक मिनट रुक जाओ यार, क्यों बार बार गड़बड़ी हो रही है?
Cos 30 positive but I sin 2 pi minus है ना सर उससे पहले?
कहाँ पे? यहाँ?
इससे ऊपर वाली स्टेप में माइनस है ना पहले?
हाँ.
तो सर नेगेटिव ही आएगा ना नीचे भी?
आई में सर -1/2 प्लस लिखा है आपने.
प्लस हो गया सर.
Sir, you took e power in the numerator. Actually, it should be in the denominator, right?
Sir, I is equal to में pi I by 6 minus pi I by 3 into -1/2. वहाँ माइनस आएगा.
नहीं यहाँ तक ठीक है सारा? यहाँ तक?
Yes sir.
Yes sir.
Okay, just wait. So this has become I is equal to minus pi I by 6, and here plus minus pi I by 3, and in bracket. So the first one is cos of 120. That will become
Minus
cos
1/2.
of, so that will become -1/2. Okay, and minus iota sine of 120. So
Root
that
3/2.
Root
3/2. 3/2.
सर
So this
Sir?
will, हाँ बोलो.
सर यहाँ पे 2 मल्टीप्लाई आएगा क्योंकि ये जो cos 2 pi by 3 minus I sin 2 pi by 3 है, इसके साथ सर 2 मल्टीप्लाई आएगा एक और.
नहीं, ये रेसिड्यू है, वो ऑलरेडी पहले मल्टीप्लाई किया होगा मैंने, देखो जहां पे रेसिड्यू निकाला होगा.
Yes sir. Yes.
That I have already done.
सर हो चुका है मल्टीप्लाई.
Yes sir.
So plus pi I by 6, and what about this? Minus plus and then minus again, na? Minus
Yes.
pi
Root 3 by 6.
by 6. So this will be
6.
cancelled and it will be minus pi root 3 by 6.
Yes sir.
Okay. वो जो please see that residue वाला thing. Why are you confusing? Residue, I have taken care of that too while calculating residue. Please see that. Is that okay? So this is a good question, na?
Sir.
Sir, previous one solution was right. Sir, if cos 2 pi minus I sin 2 pi was there, then the pole will be out of contour.
Arey, this is not pole, this is residue.
But sir, the expansion is e to the power I raised 2 pi by 3, no? Sir, then it will be plus I, no?
No, ये कहाँ से आया है?
Sir, e to the power I Z1.
अरे वो डिनोमिनेटर में है, फिर ऊपर चला जाता है. देखो ना अभी जो रेसिड्यू निकाला है, ये this is different, and then when you will calculate residue, what will be the residue for this? Again I am doing it, okay? let me calculate the residue again. Don't get confused. So suppose I calculate residue. What will be the residue? Z over minus 3z square.
Okay, sir. I get it.
This is a very common confusion, that you see the residue and then you start thinking, oh, minus is there, how I am including it? The inclusion will be according to the pole, not according to the residue. That should be clear. Okay. So write as a homework, do this question again. Okay. So now we have to discuss a little bit about some multi-valued functions. In short, we have to discuss about the multi-valued functions and especially the branch point singularity, because like you have singularities when your function is not defined. Okay. When you set denominator equal to 0, or in tan, suppose tan is there, so even in numerator you will have to see, suppose only tan z is written, fz is equal to tan z, so you will have to see that that can be divided into sin z by cos z, and then you set cos z is equal to 0. So this is one type of singularity, when at that particular point your function becomes not defined. For example, 1 upon z minus 1, z is equal to 1 is a simple pole. That means it is a kind of singularity. If we try to calculate the value of this function at z is equal to 1, so we won't get anything. Okay. So there are some removable singularities also. For example, suppose it is sin x by x. So denominator says that x is equal to 0 is a singularity, but you have a limiting value 1. Limit of sin x by x is 1. So that is another story. Here the singularity is of different type. The function will not become infinite, or it will not become not defined, but it will have many values. So अगर एक ही point पे, suppose at a single point you have so many values, and because of a point you have so many values of a function, then the function is known as multi-valued function, and that is also considered to be one of the singularities. That is also considered to be one of the singularities, because you don't know which value to take. So let me see an interesting function. Fz is equal to log of z minus 0. Okay, that means log z. Suppose let us understand this function. If I write this function in polar form, this will give me log of r e to the power I theta, which is log of r plus I theta. And if I write the general value of theta, because of the behavior of theta, I can write the general value as theta plus 2n pi. And suppose this is a particular value in Argand plane here, where this is theta and this is r, and this is some point z. Okay, itna clear hai? This we have done earlier also. So now what is going to happen, if I start moving from here, and if I take one circle, full circle, we will end up changing the position, because you see, this is real part, this is imaginary part, and if there is any addition in imaginary part, the modulus of this function will be changed. Obvious है ना, because modulus is given by under root of real square plus imaginary square. So you will arrive to a new function, I mean new value of function, and if you take another run, you will arrive again to a new value. So that is happening because of this radial vector connected to the origin, which was here. So in this case, we call 0 as a branch point, singularity. The reason is, if we don't include this, if I just move from here to here, then that will not happen. Dekho, if radius vector is like that and you move, no change in the magnitude will take place. But if you take full circle, then the addition will take place and you get a branch point singularity. So 0 is also branch point singularity, and similarly infinity is also branch point singularity. Z is equal to infinity in this case. So the rule is that, suppose if you have a function log of z minus z naught to the power a and z minus z naught 1 to the power b. Suppose there are two different points. So what we will say, that z0 is a branch point, z01 is also a branch point, and we will see a plus b. If the value of a plus b is an integer or non-integer. So depending on that, the value of infinity as a branch point will be considered. So here infinity will be included and here it will not be included. So let me take an example. तो पहला जो हमारा part है, that is just so ये सब निकालने के लिए बहुत सारी limits वगैरह निकालनी पड़ती हैं, but I am telling you in short. So let us take this. Fz is equal to log of z minus 2 to the power half, z minus 3 to the power half. This first example. And second example is f of z log of z minus 2 to the power half. So in this case, what are the branch points? 2 and 3. And infinity will not be a branch point because half plus half will become an integer. And in this case, 2 and infinity will be a branch point. So the first step is to recognize. Is that clear from this example?
सर रूल्स में आपने लिखा है कि a प्लस बी इंटीजर हो तो इन्फिनिटी इंक्लूड करना है?
नहीं करना है.
नहीं करना है, ठीक.
नॉन इंटीजर में इंक्लूड नहीं करना है बोला.
Just let me write again. If a plus b is integer, infinity will not be a branch point, and if it is a non-integer, then infinity will be a branch point. So similarly, please see this. Fz is equal to z to the power 1 by 2. this is also a multi-valued function. Fz is equal to z to the power 1 by 2. So if you write it, it will become z minus 0 to the power half. So 0 is a branch point. Because if I write z to the power half is equal to omega, suppose in some omega space, so omega square will become z. Omega square will become z. So that means the value of omega can be under root z and minus under root z. Are you understanding? So that also becomes a multi-valued function because of this 0. And the rules are very similar. So 0 is a branch point and infinity is also a branch point. But if I write a function like this, z to the power half and z minus 1 to the power half, okay, then 0 and 1 are the branch points. Is that clear?
Yes, sir.
So branch point singularity is about becoming the function multi-valued. It is not that kind of singularity in which the function become infinite or not defined. Here so many values make the confusion where we call that a singularity, and the methods to calculate the branch point I have explained you. Actually our main motive is again to solve the contour integrations involving branch point. That is our motive. So that's why I am saying that first of all quickly learn this method and why this is so, why the addition becomes so. That is again a story of limits कि अगर power इंटीजर हो जाए तो लिमिट में इंफिनिटी finite point हो जाता है. So that let us not go into that, okay, because focus is something else na. Focus is contour integration. So that's why. Tell me if I ask you about the branch points, it is clear or not? So only purpose
ये z to power half branch point समझ में आया.
z to the power half, even z to the power 1 by 3 also. ऐसा नहीं कि z to power half ही है. This will be also a branch point.
This is how multi-valued.
Because if you try to analyze this z to the power half, suppose you convert it into some omega plane. जैसे z plane है वैसे omega plane ले लेते हैं, ठीक है. Omega plane में suppose z to the power half is equal to suppose omega. So what will be the value of z there? That will be omega square. तो जब तुम वापस इस प्लेन में देखोगे तो you will get two values, plus of z to the power half and minus of z to the power half. ठीक है. So that means अगर मैं एक ट्रांसफॉर्मेशन कर रहा हूं, so I am not getting a unique value. That is a very simple transformation to make, but I am not getting the unique value. ठीक है. And अगर तुम देखो इसको सॉल्व करना चाहो वैसे भी तो तुम्हें फाइनली तो लॉग ही लेना पड़ेगा इस पावर को हटाने के लिए.
सर ये पैराबोला की इक्वेशन टाइप है ना?
No, this is not parabola. This is power half ना. So suppose y is equal to x to the power half. Is x is equal to y square. So x is
सर वो जीरो ब्रांच पॉइंट में समझ में आया, पर वो इनफाइनाइट कैसा है वही समझ में नहीं आ रहा है वहां पे.
जो बिहेवियर जीरो के साथ है, जैसे तुम जीरो को सेंटर लेके मैं समझा पा रहा हूं कि दैट इज हैपनिंग, द सेम थिंग इज हैपनिंग एट इंफिनिटी ऑल्सो. The same thing will happen at infinity. So when we go into limits and calculate all those things, we get same things there also.
Okay, sir.
Okay.
Okay, sir.
So अभी जो पूछ रहे थे z to the power half वाला, समझ आया?
Yes, sir.
तो तुम इस तरीके से दो फोटो बना लो, एक z प्लेन लिख लो, एक ओमेगा प्लेन लिख लो, and if you transform, then you see backward will give us 2 points. So that is making the function multi-valued. Okay?
सर ये रूल हमेशा वर्कआउट होगा ना, जब भी जीरो
हमेशा
आएगा
हमेशा
तभी infinitely.
always. So that's why is the rule, otherwise why?
Okay, sir. Thank you.
So why I am not going into, I can, so there is a possibility of 10 classes on branch point, but our aim is to quickly just know that this is branch point and then solve contour integration. So that will be very, suppose there is an integration in which log of z is there. So आप quickly समझ जाओगे कि नहीं कि log z is there, that means z is equal to 0 is a branch point. So we have to take care of that in some, I will tell how we take care of that. ठीक है?
सर
फिर नेक्स्ट क्लास में डिस्कस करेंगे. हाँ बताओ जल्दी से, एक क्वेश्चन और.
छोटा सा ये कि ग्राफ में जैसे हम प्लॉट करते हैं कंटूर का जो ग्राफ होता है, उसमें ब्रांच पॉइंट कुछ अलग से दिखेगा या सिमिलर पोल्स की तरह?
नहीं, वो बिल्कुल पोल्स जैसा ही दिखेगा. अब suppose there is a function like this, fz is equal to ln of z plus iota z minus 1. So what are the singular points? So you will make an argand plane. So 1 is here and minus iota is here and 0 is here. So these three singular points are there. Fine?
Yes, sir.
Okay. Thank you so much.